All right, so I think we're recording here. Let's take a look at these three quadratic equations. The directions, although I didn't cut and paste them on here, say to solve this by factoring. So let's jump in and take a look at number 7. This is not in standard form, so let's get it in standard form. Let's take away y squared from each side. 9 times y squared minus 1y squared is 8y squared. Let's add 5y to each side. That'll make that minus 40y is equal to 0. So here we have a binomial. We don't have to do the x method here. I suppose you could if you wanted to write plus 0, but it's easiest to just look at this and say the greatest common factor of these two terms is 8y. And if we factor out an 8y, or if you don't see that, if people want to write this as 8y times y minus 8y times 5. And then you can see that what's common to both of these terms is this 8y. If we factor out an 8y, what we have left in the first term is just y. What we have left in the second term is 5. So this splits into two equations where 8 times y is equal to 0, or that y minus 5 is equal to 0. And these easily solve to y equals 0 and y equals 5. And those are our two solutions. Let's take a look at this next one. It's not in standard form. Let's subtract 8 from each side. So we have 5 times c squared plus 39 times c minus 8 is equal to 0. So the directions said to do it by factoring. So let's multiply the first term times the last term, place that at the top of our x, and put the middle term at the bottom of our x. Two numbers, when multiplied together, give us the top value, but when added, give us the bottom. And of course, let's make a table to help us factor this. The table is a nice organized way to apply the distributive property. Along one diagonal, we put the first term and the last term, and along the other diagonal, the two values that we found in our x. So we see here that 8 divides both of those, that negative 1 is common to both of those, that c is common to both of these, and that 5c here. So let's double check and make sure I haven't made a silly mistake. 1c times 5c is 5c squared. 8 times 5c, 40c. 1c times negative 1 is negative 1c, and positive 8 times negative 1 is negative 8. So it looks like that I've done that correctly. Let's write down our binomials. C plus 8 times 5c minus 1. And remember to set it equal to 0. You want to write in complete equations. In English, they expect you to write in complete sentences and use proper punctuation. And in mathematics, you need to write in complete equations and illustrate that one equation above is equivalent to the equation below, that they both have the same solution set. So here, this splits into two equations. So we have solutions of negative 8 and positive 1/5. All right, so let's take a look at number 9. So this is a quadratic equation, but it's not in standard form. Let's leave the 2a squared where it is because I like to have a positive leading coefficient. Let's take away 2a from each side. 7a, take away 2a's will leave me with 5a's. Let's take away 5 from each side, and 2 minus 5 is a negative 3. So let's use the x method. The directions did say to solve this by factoring. So the bottom of the x is the middle term. The first term times the last term is written at the top of the x. And now the trial and error begins. You're looking for two numbers that when multiplied together give us the top value, but yet when added, give us the bottom. So 6a times a negative 1a, I think, does the trick. When you multiply those together, you get the top expression. When you add these together, you get the bottom expression. So let's put this in the form of a table. We always put the first term and the last term from the original equation that was written in standard form along one diagonal, and the values that we found within the x along the other diagonal. Then factor what's common to each. I don't know why I put squared there. And negative 1. So we have 1a times 2a is 2a squared. 1a times a negative 1 is negative 1a. 3 times 2a is 6a, and positive 3 times negative 1 is negative 3. So that means that this trinomial factors, that this equation has the same solution set as the equation a plus 3 times 2a minus 1 is equal to 0. It was difficult in the trinomial to just look at that and see what values of a satisfy that equation, but in factored form, it's far easier to see that negative 3 plus positive 3 give you 0, or that half of 2 is 1 and 1 minus 1 gives you 0. All right, so there's our answer. Hope that helps. Don't be afraid to ask questions, and I will talk to you later. Bye.